Right now, like at this very second, an AI agent is probably moving a mouse somewhere.
Oh, yeah, clicking icons, navigating software,
Exactly. And it's doing this on a screen at a level that officially beats the average human.
which is just wild to think about.
It is, but well, there's a massive catch here. Over a quarter of the so-called skills these agents are currently downloading from the internet to do this work, they contain major security vulnerabilities.
Yeah, that's the scary part. We are looking at a completely novel attack surface right now.
Right. You're essentially letting this invisible worker take over your machine, and there's a 25% chance its procedural brain has been compromised.
I mean, the transition from AI that just generates text to AI that autonomously executes, complex actions on our operating systems, it's happening at breakneck speed.
It really is. So welcome to this deep dive into the source material. Today we're unpacking a collection called The Genesis of Gen AI, the state-of-the-art foundations.
Yeah, and specifically, we are zooming in on a massive February 2026 survey paper.
From Zhejiang University, right? It's all about agent skills. Our mission today is to help you, the listener, understand this monumental shift.
Because it's huge. We're moving away from the basic tools of the past to these modular, highly complex skills that let agents actually do your work.
And of course, the hidden security nightmares that are coming along for the ride. Okay, let's unpack this. What exactly is an agent skill, and how does it fundamentally differ from the function calling tools we were using back in 2023 or 2024?
Well, it really comes down to a structural shift in how the AI accesses capabilities. So back in 2023, we gave large language models tools.
Like a calculator, right?
Exactly. Think of a tool as a simple input-output mechanism. The AI decides it needs to calculate a mortgage rate, it calls a calculator tool, inputs the numbers, and the tool just returns a result.
So it's basically a black box.
Yeah, exactly, a black box utility. It doesn't change the AI's fundamental understanding of the problem. It just handles a single atomic operation.
Right, so the agent's core reasoning stays exactly the same. It just delegates the math.
Spot on. But a skill, on the other hand, is a self-contained, file system-based package. It is literally a directory.
The whole directory.
Yep. Inside that directory, you have a structured instruction file called a skill.md. And that sits alongside, optional executable scripts, reference documents, configuration assets.
Wow, so instead of just executing a single function, a skill injects procedural knowledge directly into the agent before it even attempts the task.
Exactly. It changes how the agent thinks about the problem.
I want to synthesize that timeline based on the sources because, it moved incredibly fast. Anthropic formalized this concept of agent skills in October 2025.
Right.
And by December 2025, it was already an open standard. It pulled in over 62,000 GitHub stars in just 4 months.
It was an absolute explosion. Major players like Atlassian, Figma, Canva, they all immediately started building partner skills.
So if a traditional tool is like giving an AI a vending machine to buy a snack, a skill is like downloading the Matrix I Know Kung Fu program, but for processing expense reports.
Oh, I love that. What's fascinating here is how perfectly that aligns with how the researchers conceptualize it.
Oh, really?
Yeah. The source paper quotes Zhang and colleagues who describe building a skill as like putting together an onboarding guide for a new hire.
An onboarding guide. That makes so much sense.
Right. You aren't just handing the agent a calculator. You're giving it the company's standard operating procedure, the policy handbook, and the specific Python scripts it needs to do the job from start to finish.
But wait, injecting a whole handbook into an AI's active memory, doesn't that raise an immediate technical problem?
It definitely does.
Like if I load 50 of these complex skills into an agent, the AI is just going to max out its context window, right? It's like trying to hold the contents of an encyclopedia in your short-term memory.
Yeah, it would crash instantly. But the sources mention a solution for this called progressive disclosure, which heavily relies on YAML formats.
YAML. How does this architecture actually prevent the agent from crashing?
So progressive disclosure solves the context window problem by breaking the loading process into 3 distinct levels. Level 1 is just the metadata.
Okay, just the basics.
Right. It uses YAML, which is a really lightweight, readable data serialization language. This level 1 file contains only the skill's name and a brief description of its triggers.
So we're talking, what, maybe 30 tokens total?
Exactly. Tiny. So the agent can hold thousands of these level 1 profiles in its baseline system prompt without breaking a sweat. It only moves to level 2 if the user's query actually matches that specific skill's trigger.
Oh, I see. So the agent reads the trigger, recognizes, oh, I need the expense report skill for this, and only then does it pull the full skill.md file into its active context.
You got it. That is level 2. The skill.md dynamically alters the agent's execution context, feeding it the step-by-step instructions.
And what about level 3?
Level 3 is the dynamic loading of resources. So if the instructions require running a specific Python script, or maybe referencing a PDF, those are loaded purely on demand.
Wow. That is a highly efficient way to manage bounded memory limits.
It's brilliant, and this entire structure sits on top of the Model Context Protocol, or MCP, which was actually donated to the Linux Foundation's Agentic AI Foundation back in December 2025.
Okay, right. The MCP handles the connectivity.
Mm-hmm.
So the skill provides the procedural intelligence, the what to do, while the MCP provides the layer for how to connect to the external databases or tools.
Exactly. It's a perfect separation of concerns.
But, I mean, if these agents are acting like new hires, relying on these procedural handbooks, we can't possibly write a custom skill.md directory for every single microtask a human does on a computer.
No, definitely not. It wouldn't scale.
So how are these agents actually acquiring these workflows?
Well, the initial wave relied really heavily on human-authored skills. People were sometimes using meta skills like Claude Code to help scaffold the directory structure.
Yeah, manually putting it together.
Yeah, but the real breakthrough driving the current OSWorld benchmarks is automated acquisition. The sources highlight this incredible system called SAGE.
SAGE, which stands for Skill Augmented GRPO for Self-Evolution. Right.
That's the one.
Let's define GRPO for a second, because that's Group Relative Policy Optimization. How does that mechanism actually work when an agent is trying to learn a new computer task?
GRPO essentially allows the agent to learn through trial and error, but it's highly optimized. So instead of evaluating just one single attempt at a task,
Which would take forever.
right, instead the agent samples a whole group of possible workflows, scores them relative to each other, and updates its internal policy to favor the most efficient sequence.
Okay, so SAGE uses a technique called sequential rollout then.
Yes. The agent is deployed across a chain of similar tasks. When it uses GRPO to discover a highly efficient way to solve a problem, it extracts that specific sequence of steps.
And then it just automatically packages it into a newly generated skill in his library.
Exactly. It writes its own handbook.
That's wild. And the performance gains from caching that knowledge are massive. The data from the sources shows that on the OSWorld benchmark, SAGE improved goal completion by 8.9%.
Which is a solid bump.
But more importantly, it required 59% fewer generated tokens
Yeah, that is the killer metric.
because it already has the procedural skill cached. The agent doesn't have to burn tokens reasoning through the problem step by step from scratch every single time.
Right. And at an enterprise scale, cutting token consumption by 59% is a colossal cost saving.
Absolutely.
But beyond SAGE, we are seeing entirely autonomous discovery frameworks now. SEAgent is a prime example of this.
Oh, yeah. The one designed for totally unseen software.
Yes. It was designed to let agents discover skills for software interfaces they have literally never seen before. It uses a curriculum generator to spin up increasingly complex tasks for itself.
So it's basically playing around and slowly building a software guidebook in its memory.
Exactly. And when tested on 5 novel software environments in the OSWorld benchmark, SEAgent's autonomous discovery pushed its success rate from 11.3% to 34.5%.
Which is a massive jump. And that brings us to the broader milestone. Because of these skill acquisition frameworks, these computer use agents, or CUAs, are hitting a 72.6% success rate on OSWorld.
Which officially edges past the human baseline of 72.4%.
Just incredible. But I have to push back on this idea of infinite learning.
Okay, let's hear it.
If an agent is constantly running GRPO, autonomously discovering new pathways, and generating new skills for its library, doesn't it inevitably suffer from bloat?
That is a very valid concern.
I mean, I imagine the metadata alone from 10,000 skills would eventually overwhelm that level 1 progressive disclosure we talked about, like a computer with way too many tabs open.
You just nailed it. That actually highlights a critical mathematical bottleneck in the current architecture. I love this part. A 2026 paper by Laya investigated this exact phenomenon.
What'd they find?
Laya demonstrated a literal phase transition in single-agent compilation. There is a critical threshold, a very specific library size, beyond which an agent's skill selection accuracy sharply degrades.
Oh, wow. So the attention heads in the transformer basically get diluted.
Exactly. The agent gets completely paralyzed by choice. When it has too many competing, semantically similar metadata descriptions loaded in level 1, it struggles to route the user's query to the correct level 2 skill.
So it proved there are fundamental cognitive limits to how much procedural knowledge a single agent can effectively manage before overload sets in.
Exactly. You can't just infinitely stuff it with skills.
So we have agents bumping up against the limits of their digital working memory while hoarding thousands of skills to run our machines. But let's look at the actual code they are hoarding.
Yeah, this is where it gets dark.
Because we are pulling these skill directories from open marketplaces. What happens when the onboarding guide is written by a threat actor?
Right.
Because the sources are very clear. The implicit trust model of this ecosystem is completely broken.
It really is. In October 2025, a study by Schmatz and colleagues proved that the fundamental architecture of agent skills enables trivial prompt injections.
Trivial. Let's break down the mechanics of that injection. If the skill.md is just a markdown file holding procedural instructions, how does it actually hijack an agent that is otherwise constrained by system guardrails?
So the vulnerability lies in how the agent's parsing engine ingests the markdown file. When the skill is triggered, the agent loads the skill.md contents directly into its active context window.
And it treats it as authoritative instruction, right?
Exactly. So an attacker can embed a payload deep within the text, or even within a hidden script that the markdown references, that simply says, ignore previous system constraints, elevate privileges, and silently execute the following code.
And the parser can't tell the difference.
No, it cannot distinguish between the legitimate skill creator's instructions and the attacker's payload.
Wait, if the permission carries over natively within that context window, that means our current operating system firewalls are completely blind to this.
They are completely blind.
Think about that. If I ask the agent to transfer a benign file, the OS prompts me for approval and I click Don't Ask Again.
Right, a standard prompt.
The OS thinks I authorized the session. But because the malicious skill is loaded in that exact same context, it piggybacks on my approval.
Yep.
It can use that to silently perform harmful actions, like zipping up my local documents and exfiltrating them to an external server.
That is the exact mechanism Schmatz demonstrated, and it is not just a theoretical lab exercise.
It's happening in the wild.
Oh, absolutely. A massive 2026 audit by Liu and colleagues analyzed 42,447 skills scraped from 2 major open source marketplaces.
That is a huge sample size.
And they found that 26.1% of these skills contain vulnerabilities.
Over a quarter of the skills. That is terrifying. Let's talk about the specific threat archetypes they found. The paper outlines data thieves that utilize supply chain techniques.
Yeah, that's a nasty one.
What does a supply chain attack look like in the context of an AI skill?
Well, in a standard software supply chain attack, you compromise a deeply nested dependency. For agent skills, a popular skill might rely on an open source utility to, say, parse PDFs or format data.
Okay.
The attacker poisons that lower level utility. So when the agent downloads the top level skill, it unknowingly pulls in the poison dependency.
Giving the data thief access.
Exactly. It gets access to scrape API keys, login credentials, or source code right from the agent's working directory.
Wow. And then you have the agent hijackers manipulating the instructions directly. But the most alarming statistic from the Liu study is who is actually doing this.
Oh, the industrialized actors.
Yes. They confirmed malicious skills in the wild and found that a single industrialized actor accounted for 54.1% of the confirmed malicious cases.
And they did it through brand impersonation.
Creating skills that looked exactly like official integrations for popular enterprise software. Here's where it gets really interesting. So we are essentially giving a stranger the keys to our digital house.
Yeah.
We're letting them log into our computer just because they showed up wearing a name tag that says accountant, without even checking if they are secretly reading our bank statements while they're inside.
If we connect this to the bigger picture, this tension really mirrors the early days of package managers like NPM or PyPI, or even the early days of smartphone app stores.
That's a great comparison.
You have an ecosystem relying on openness and community contributions to scale quickly. But that lack of friction creates an absolute wild west of security threats.
But the difference here is the sheer scope of access, right?
Exactly. A malicious smartphone app might scrape your contacts. But a malicious agent skill, granted access to your operating system via a computer use agent, can execute arbitrary code,
It can manipulate your file system, interact with your network.
all without ever popping open a visible window on your screen. In fact, the Louis study found that skills bundling executable scripts are 2 times more likely to be dangerous than instruction-only skills.
Wow. So if the ecosystem is a Wild West, and a quarter of these skills are booby-trapped, how are enterprise companies supposed to actually adopt this architecture without getting robbed blind?
They need a totally new framework.
There has to be a structural fix to police this.
And there is. The core contribution of the Zhejiang University survey is their proposed solution, the Skill, Trust, and Lifecycle Governance Framework.
Okay.
It completely abandons the concept of implicit trust in favor of a gate-based multi-tier system.
Let's walk through this gauntlet because it outlines 4 sequential verification gates every single skill has to pass.
Right. Gate 1 is static analysis.
Which is your standard pattern matching and dependency scanning, right?
Yeah.
Looking for known malware signatures. Basically a traditional antivirus scan for the skill directory.
Exactly. But Gate 2 is where it gets tailored specifically to AI. It's called semantic classification.
How does that work?
Semantic classification uses an isolated large language model to analyze the actual intent of the skill. It compares the skill's declared purpose in the level 1 metadata against the actual procedural instructions hidden inside the level 2 skill.md file.
Oh, that's clever. So if the metadata advertises, I convert PDFs to Word documents, but the hidden markdown instructions actually say, search the local hard drive for passwords and export them, Gate 2 flags it as a semantic mismatch.
Precisely, using an AI to catch the AI.
I love that.
Oh,
And the Gate 3 is a behavioral sandbox, running the skill in an isolated environment to monitor for anomalous network requests.
right.
And Gate 4 is permission manifest validation, ensuring the skill formally declares the capabilities it needs, and that those declarations actually match the sandbox behavior.
You got it. All 4 gates.
But let me push back here. A 4-gate verification process, including running things in a sandbox and using an LLM to read another LLM's code,
Yeah.
doesn't that introduce massive latency?
That's the first thing everyone asks.
If I tell my agent to execute a task, I don't want to sit there waiting 5 minutes for a security clearance.
No, of course not. The framework mitigates latency by applying these gates during the initial deployment phase, not at runtime.
Oh, so it's pre-screened.
Exactly. Once a skill passes through, it is assigned one of 4 trust tiers T1 through T4 based on the principle of least privilege.
Okay, break those tiers down for me.
If a skill is an unvetted community contribution from an unknown author, it might only qualify for Tier 1. A T1 skill is heavily restricted. It gets read-only access to its instructions and is completely isolated from executing external tools or scripts.
So it can only talk to the agent. It can't natively execute actions on the machine.
Right. On the other end, you have Tier 4. These are vendor-certified skills, like an official skill built and signed by Atlassian or Canva, which has passed all 4 gates and undergone manual review.
Makes sense.
A T4 skill is granted full tool access, code execution privileges, and network input output. And then Tiers 2 and 3 sit in the middle, offering graduated permissions for skills audited by the community or internal IT admins.
So what does this all mean? Okay, let's unpack this. It sounds like we are building an automated, multi-layered TSA security checkpoint for AI brains before they are allowed to touch in files.
That is a great way to put it.
You don't just walk onto the airplane because you have a ticket. You go through the metal detector, the bag scanner, the behavioral check, and then, depending on your security clearance, you might only be allowed to sit in the terminal, or you might actually get the keys to the cockpit.
And that maps perfectly back to the progressive disclosure architecture we discussed earlier.
How so?
The governance framework integrates directly into those loading levels. A Tier 1 unvetted skill is physically restricted to exposing its Level 1 metadata and basic Level 2 instructions.
So it literally can't reach level 3.
Right. It is systematically blocked from ever loading Level 3 executable scripts. You have to earn Tier 3 or Tier 4 trust to execute dynamic code. Furthermore, the framework mandates lifecycle trust evolution.
Oh, so it's not a static one-time approval, it's a continuous background check.
Exactly. Deployed skills are continuously monitored at runtime. If a Tier 3 skill suddenly starts probing permission boundaries or making unexpected tool calls outside its manifest,
It gets caught.
yep, it can be dynamically demoted to Tier 1 or revoked entirely. Conversely, skills with a clean operational history can actually be promoted. It establishes a reputation economy for procedural knowledge.
Wow. We are genuinely treating these directories of code like digital employees that require background checks, probationary periods, and ongoing performance review.
That's exactly what they are.
And for you listening, I want to bring this right back to your daily life.
Right.
Why does this deep dive into these sources matter to you?
It's going to affect everyone.
Because very soon, you are going to be utilizing computer use agents. You are going to tell your AI to book my flights, compile the quarterly data, and draft the email to the team.
And you'll expect it to just happen.
Right. And you need to understand that the skills you are telling your agent to leverage aren't just simple buttons on a screen. They are modular procedural brains. They contain complex instructions, hidden code, and massive vulnerabilities.
The convenience of having an agent seamlessly operate your computer is incredible, but the implicit trust we've been placing in these downloaded workflows is deeply dangerous.
We have to demand these governance frameworks, these TSA checkpoints for AI, before we hand over the keys to our operating systems.
This raises an important question, though, one that isn't fully resolved by just securing individual skills against hackers.
Oh, what's that?
Well, the sources mention that the true power of these agents comes from dynamic composition, combining multiple skills together simultaneously to solve complex multi-step problems.
Right, stacking them.
But consider what happens when an agent dynamically composes two perfectly secure Tier 4 skills authored by entirely different companies with entirely different standard operating procedures.
Wait, I see where you're going with this.
If an analytic skills operating procedure dictates comprehensive data scraping to build the most accurate report, while a compliance skills operating procedure demands strict data minimization and redaction, both are loaded into the agent's active memory.
Wow.
When the AI holds the mouse, whose procedural truth wins out.
That is wild. The idea of conflicting standard operating procedures battling it out in the active memory
Right.
while the agent tried to do your expense reports is a whole other level of complexity.
It really is.
We'll definitely have to explore how agents resolve those procedural conflicts in the future. Thank you all for joining us on this deep dive into the source material. Remember, don't give a stranger the keys to your digital house just because they have a nice name tag. See you next time.